Okay, so the next test portion, that is 8.1C, these are the portions. Okay, start with the first one, B9. Quite simple if you follow by listening carefully. Okay, in triangle ABC, right angle at B. Let's draw that triangle. ABC, right angle at B means should be here, and A and C can be anywhere you like to put. Then let us write here. You can put A here and C there, so that's up to you now. So in right, in triangle they are writing like that, so follow the same style. In triangle ABC, right angled at B. Okay, so this is given to us. So right angle at B. So let's just mention once. Let's take this angle A as A, and this C, the other acute angle C as C. This is right here given to us. So the trick behind doing it properly is not to hurry, but allow yourself to think a lot. Okay, think a lot. And also I would suggest imagine a lot. Makes your job a lot easier when you're willing to not hurry, think a lot in between, and have a good imagination, like you're able to imagine, use your imagination. Okay, then it becomes easier to solve. None of the questions are difficult if you are willing to do that. So let's write here given 10A. That is given, it means given in the question, is equal to, look into your textbook and tell the value. Yes, 1 by root 3. So that implies, we know by now, very well versed, 10 means opposite by adjacent. So if you take this A, then these are the two arms of angle A. This one, which is not the arm, will become opposite. Don't mark, okay, because two angles are involved now. And then adjacent will be this one, and hypotenuse will be this one. So O by A would mean OBC by A here, AB, will be equal to 1 by, so this is the opposite by adjacent, then 1 by root 3. So that allows us to write, let BC equal to 1 and AB value equal to root 3. I hope you're getting right. Now here BC, so let's remove it because we don't need it anymore. So BC is found 1 and AB is root 3. So the unknown side is the SC. So let us write here, when we don't know the third side in a right triangle, we can easily find it out by using Pythagoras theorem. That's right. Okay, by using Pythagoras theorem, the unknown side Pythagoras hypotenuse AC square, then it's always plus, right? AB square plus BC square. I hope Pythagoras equation, there is no more confusion, right? We have done this separately in as one class, right? Because it's important. So here AC, if you remove the square, then root will come. And AB, if you see here, is root 3. So you write there root 3. Bracket, you put it to avoid confusion. Plus BC is 1. Here we put bracket also null, so it's fine. It's a single number, right? It's a clear number. So not assert, not an irrational number like this. So root 3 square means we know the root will get cancelled, so no more root. This root is there, the inside root will get cancelled, square and root cancelled. You don't need to show, but if you want to show, then you can show like this. Square power and this root. No more root. Plus 1 square. 1 ones are 1. So that will be equal to, here, root over 4, and 2 2s are 4, so 2. No more root. So this value also 2, this root 3, and all the three sides of the triangle are known. So you can evaluate and find out number 1, find the value of sine A into cos C plus cos A into sin C. Cos A into sin C. So as I said, the idea behind doing it is not to hurry, but to think a lot. So sine is opposite by hypotenuse. Angle is A. So if you take A, this is adjacent, this is opposite. The two arms of angle A are AB and AC. So BC, which is not the arm, is opposite. This is adjacent. And this is always hypotenuse. So opposite by hypotenuse would mean when you take A, opposite is BC. Hypotenuse is AC. I'll do directly here. Cos is adjacent by hypotenuse. But the angle is C. So when you take C, these are the two arms of angle C. So this one which is not the arm become opposite. And so the adjacent is BC when you take angle C. So adjacent is BC. Hypotenuse is the same, AC. Plus cos A. A again. So the two arms of angle A are AB and AC. The one which is not the arm becomes opposite, BC. So AB is the adjacent. And cos is adjacent by hypotenuse. So adjacent is now AB when you take angle A. By hypotenuse is AC. And then when you take sin C, C is this angle. So CB and CA are its arms. And which is not the arm, AB is opposite. And so adjacent is BC. Opposite, adjacent. So opposite, sine is opposite by hypotenuse. So opposite, when you take C, AB is the opposite by hypotenuse AC. So get these things correctly is the main thing. The remaining are just a matter of doing it patiently and solving it. One mistake here and you will get a wrong answer, right? So we have to be cautious, or rather careful in this, a little bit more careful in this step. So BC by AC is the first one. So BC by AC. So BC is here 1 by AC, as we found here, AC has been found to be 2. So 2 BC, sorry, BC. BC is 1, so write your 1 into, again, BC. AC is 2, just as you can see there, plus AB. So AB is root 3, as you can see here. So write your root 3 by AC, all that we put, so the 1 and AB again, so same thing, root 3 by AC 2. Matter of solving carefully. So 1 1s are 1. This dot means into, so 2 2s are 4. Plus root 3 into root 3 means the root will disappear. 2 2s are 4. So here 4 is the LCM. Take the first denominator. 4, how much is this LCM 4? That's right, 1. 4 1s are 4, so 1 1s are 1. No need to write this, okay? I'm writing it to explain it. And once you got that, same thing, 4 1s are 4, so 1 3s are 3. And we know 1 plus 3 is 4, and down here also 4. So 4 1s are 4, 4 1s are 4, so 1 by 1 is 1. 4 divided by 4 is 1. First answer. Let's go and do the second one. Number 2. Find the value of cos A cos C minus sin A sin C. Cos A into cos C minus sin A into sin C. And let's do slowly. This step is the crucial, important step. A angle means the two arms are AB and AC, which is not the arm. BC is the opposite. So this is the adjacent. So cos is adjacent, so AB by hypotenuse AC. Then when you take C, the two arms of angle C are CB and CA. This is opposite, therefore, and so BC is the adjacent. So adjacent, BC by hypotenuse again, AC. Hypotenuse won't change because hypotenuse is determined by this 90-degree point, right? Minus sin A. A again means the two arms of angle A are AB and AC. BC, which is not the arm, is opposite, so AB is the adjacent. Opposite we need, so BC hypotenuse AC. When you take angle C, then two arms are CB and CA. The one AB, which is not the arm of angle C, is the opposite, so sine is opposite, so AB by hypotenuse AC. So once we're through with that, then AB by AC. AB by AC. Once you're through with that, the rest is quite simple. AB, as you see here, is root 3. AC, as you see here, is 2 into. BC, as you see here, is 1. By AC is 2 minus. This is same, see, BC by AC, BC by AC, so 1 by 2. AB by AC, AB by AC, so this one, root 3 by 2. So next here, root 3 ones are root 3. 2 twos are 4 minus 1 into root 3 is root 3 divided by 2 twos are down multiply 4. Answer this simple question. 3 minus 3 is how much? As this right, 0. Similarly or likewise, no sign, plus root 3 by 4 minus root 3 by 4 is also 0, right? So that's B9. Let's go to B10. So B10. Okay, so here B10. In triangle PQR, right angled at Q. Let's just draw the triangle. Right angled at Q. So PQR or PQ. Oh, sorry, Q should be here. P and R or P and R, up to you. Determine the values of sin P, cos P, tan P. Everything is P. So here also okay, but you may like to prefer here, up to you. Here also no harm, okay? So here. So let's write down in triangle PQR, right angled at the point Q given to us are PQ plus QR equal to 25 centimeter. Let us put this one as a question 1. And then PQ is equal to 5 centimeter. Let us put this one as a question number 2. Okay, so once we're through with that, let us write here PR plus PQ. Go back once. PR plus QR, sorry. PR plus QR. PR plus QR, yes. So let us write that one. PR plus QR is equal to 25 centimeter since using equation number 1, let us say. Then here that gives you PR, keep it, don't move, then 25 centimeter, don't move. If you shift this, plus QR will become minus QR. Let us put this one as equation 3 because we may need it later on. We are going to need it as we go on. So next, let's go about like this simply. So here, using Pythagoras theorem, see here, P, this hypotenuse, the two arms are 90 degree are QR and QP. So PR, which is the side of the right triangle, which is not the arm of 90, is hypotenuse, right? So this is your hypotenuse. So hypotenuse square, PR square, Pythagoras theorem equal to PQ square plus QR square, or QR square plus PQ square also mean the same thing. PQ square plus QR square. That implies PR here, as you can see here, 25 centimeter minus QR, whole thing square, because there's a square here. PR is this, and PR is squared, so I put a square here. Then next is an equal sign. Then PQ is here, you can see, 5 centimeter, and bracket is a mass, because there are two factors here, whole square. You can see equation number 2. Then QR plus QR square, you can just keep it like that. You can write here, since using equations, as you can see, PR, you use equation 3 to replace this PR by 25 minus QR, and then PQ equal to 5, we used equation 2. So these two equations are the reason why you change this to this, and this PQ to 5 centimeter. Okay, so next, once you're through with that, that will give you, that implies, keep it simple now, A minus B whole square. Very common formula in our lower classes. A minus B whole square is A square plus B square minus 2AB. Right. So let's apply that. A minus B whole square means A square, 25 centimeter whole square, plus B square, plus this B is QR, so QR square, minus 2 into, dot means into, A is 25 centimeter into B is QR. So A square plus B square minus 2AB, A square plus B square minus 2AB for A minus B whole square. Then after that, equal sign right hand side here. 5 5s are 25 centimeter square plus here QR square, we can just keep it like that. On the left side there is plus QR square, on the right side QR square means if you were to shift this plus QR square to the right side, it will become minus QR square, and plus QR squares will become 0. So you can cancel it here as well. Now 25 square is 625. 25 multiplied to 25 2 times, you can try, you will find out. 625, then centimeters also should square. Minus 2 into 25 is 50, then centimeter into QR. 50 and QR into equal to here 25 centimeter square. Now here, if you want, let us shift this minus 50 centimeter QR to the right side, then it becomes plus 50 centimeter QR. Then this one don't shift, 625 centimeter square still on the left side. And if you shift this, no sign means plus, to the left side, it will become minus 25 centimeter square. Now here 625 minus 25, very simple. 600 centimeter square is equal to 50 centimeter into QR. So QR don't move, then 600 centimeter square divided by, if you shift this 50 centimeter, it will go down to the denominator, to the left side. Then centimeter to the power 1, 2 minus 1 power gone. And this 0 and 0 can cancel. 5 1s are 5, 1 and n, 5 2s are 10. So you're getting value QR is equal to QR value, as you can see here, QR equal to 12. You may put this one as 4 if you like. QR is equal to 4. You got PQ 5, QR you got PQ 5, QR you got. So PR you can find out by using equation number 3, I think. So you can write down next here. Let's write down this one here. QR is equal to 12 centimeter. Equation number 4, let us keep it like that. This one just right after this, okay? Don't change. Then here, QR you found, PQ, QR, PQ. So the third side we can find here using this one. So putting equation 4 value in 3. We put equation 4 value in 3. What would we get? We would get 3 is this one, PR is equal to 25 centimeter minus QR, and QR in equation 4 is 12, so I put there 12 centimeter in place of QR. Then we're going to get equal to 25 minus 12 is 13 centimeter. So this is a PR, so equation number 5, let us say. All the values are fine. PR is here 13, QR is here 12, PQ is here, equation 2, 5 centimeters. So all the 3 sides are known, that of the right triangle. So now we can answer the question. The question is asking us what? Let us see and solve it. Let's see there, question is saying Find sine p, cos p, tan p. So sine p is this one. The two arms are PQ and PR. So the one which is not the arm is this one. This is PQ. This is adjacent hypotenuse. So opposite by hypotenuse. So QR by PR. By PR. QR, you can see here, 12 centimeter by PR. So PR is here. You found out 13 centimeter. You can write here since using equations. QR is question 4, and then PR 13 you're finding from equation 5. So these two cancel, so your answer is 12 by 13. Can't cancel anymore. Sine P, then next one is cos P. Okay, cos P. So cos P is adjacent by hypotenuse. So adjacent A here, PQ by PR. PQ by PR. So PQ is here 5 centimeter. So since using equations, PQ equal to 5 centimeter is in equation 2, and PR, as you can see here, PR is equal to 13 you found from 5. So this is right here 5, and here cancel these two, so your answer is 5 by 13, second answer. Okay, then last finally tan P. So tan P is opposite by adjacent, so O here, QR by adjacent, PQ. QR by PQ. So QR is here, as you can see here, 12. So you have your 12 centimeter. Since using equations 12, you're getting from 4. So write your 4, and divided by PQ is 5. So that is equation number 2. So here 5 centimeter. These two cancel, so your third answer is 12 by 5. So these are just 12 by 13, 5 by 13, 12 by 5. Number 10, the last question of this test portion, 11. Let's go there. Question number 11, page number 190. Okay, 190. So B11, this one. We'll go slow, not to hurry, that's the important thing. So B, state whether the following are true or false. Justify your answer. So question number 1, 11.1, subheading 1. The value of tan A is always less than 1. The value of tan of any angle A is always less than 1. Is this true or not? Let's check. So for this, let us take here. We know that here we know tan A of any ratio value is opposite side by adjacent side. This is the ratio, right? Now you see. What we can take is first case, for example. They're asking us to justify this. Why we're doing this. Okay, case 1 is opposite side can be equal to adjacent side. That's quite true. What we mean is if there is a right triangle and this is A, then B, C, then this is opposite adjacent hypotenuse A. Here tan A. So the two arms of A are A, B, A, C. So opposite adjacent. So opposite. Okay. Opposite side can be equal to adjacent side or not. Let's see. Absolutely correct. Adjacent and opposite 5 centimeter. Such a situation can happen in a given right triangle, opposite side in a given right triangle. Okay, in a given right triangle. In which case, if this is so, then in which case, CASE, in which case, okay, if they are equal, then common sense also 10A equal to opposite and adjacent equal means like 5 centimeter, then this also 5 means the answer will come out 1, right? So 10 value of 10A is always less than 1. It's not true already. It's not less than 1. Okay, till now this is 1. Okay, now that is correct so far. So case 2. Also, opposite side can be greater than adjacent side. Opposite side can be greater or bigger than adjacent side in a right triangle. Adjacent side. In which case, if opposite is greater than 10A will become, then A value will become greater than 1. How? Let us see here. If opposite is greater than adjacent, means opposite here, BC, maybe like 7 centimeter or 8, whatever you like. 7 or 8 or whatever, then this can be here 4. So opposite greater than adjacent, then numerator will be bigger and denominator means we know that that number is greater than 1. That's why 10A value will become greater than 1. So they're saying the value of 10A is always less than 1 is already not true from the second case. So this is a false statement. But to complete our answer, let us take the third case possible also. Case 3 is opposite side can be greater than adjacent side, in which case 10A value is surely greater than 1, because if numerator is bigger than denominator, we know that that number is greater than 1, right? Numerator had denominator or down, always the value after cancellation, for example, here is 2, already greater than 1. Okay, so opposite side can be smaller than adjacent side. Opposite side can be smaller than adjacent side, in which case 10A value, okay, opposite side can be smaller than adjacent side means numerator smaller than adjacent. If numerator is smaller than denominator, the value is always smaller than 1. If it is numerator is greater than bigger than 1, numerator is smaller than denominator, then that number is smaller than 1. So 10A value will be less than 1. 10A value is always less than 1. Sometimes it's less than 1, but that's not true. 10A value can also be greater than 1, can be equal to 1. So it's always less than 1 is not true from case 1. See, case 1, 10A value is 1. When opposite side equal to adjacent side. So they're saying always less than 1 is not true from case 1 and case 2. In case 3 only, it is there. So in all cases, it's not like that. So this statement is false. So you can write here is less than 1. Okay, then we can see there in your textbook. So we can write the answer here from cases 1, 2, and 3. From cases 1, 2, and 3, we see that value of 10A is not always less than 1. Value of 10A is not always less than 1. You see here, in case 1, it is equal to 1, not less than 1. In case 2 also, it is greater than 1, not less than 1. Only in case 3, it is less than 1. So it's not always less than 1. So this statement is false. That means the statement given in the text which says 10a value is always less than 1, that statement is false. So we can write like that. Next, we have to justify our answer. So we're doing it like this to justify it. So here. Next, 211, subheading 2, let us see. Cos A is the abbreviation for cosecant of angle A. No, 2. Sec A equal to 12 by 5 for some value of angle A. So the statement is saying sec A equal to 12 by 5 for some value of angle A. Is that correct? Let us see. Here very clearly we see 12 by 5, numerator bigger than denominator means greater than 1, right? Very clear. Numerator smaller than denominator is less than 1. Numerator bigger than denominator is always greater than 1. Keep that in mind. You know that already. Whenever numerator is greater than denominator, when you divide, the value will come out greater than 1, 1.5623 like that. Okay, so here, now, we know that sec A ratio is hypotenuse side of a right triangle divided by adjacent side. Adjacent side. We know this, we learned this in our first class. And we know the hypotenuse, and we know by definition hypotenuse is nothing but the longest side in a right triangle. This we know very clearly. In a right triangle, one angle is 90 degree. The two arms of 90 degree BA and BC. The one which is not the arm of 90 degrees AC is called hypotenuse. And this hypotenuse, another definition, it must be the longest side out of the three sides. There can be no side greater than hypotenuse in a right triangle. So longest means 7 centimeters, and these two will be less than 7, AB and BC. So we know that by our previous knowledge. So if this is so, then in other words it means that is hypotenuse is greater than adjacent, because adjacent side will surely be shorter than hypotenuse. We know this. In other words, this means that is hypotenuse, which is numerator, is greater than denominator. See, greater than denominator. Hypotenuse, which is numerator, greater than adjacent means greater than denominator. In other words, therefore, sec A, since hypotenuse is greater than this one, will always be greater than 1. Okay, so greater than 1. And here 12 by 5 is greater than 1. Already we know numerator greater than denominator. So sec A can surely be 12 by 5 because 12 by 5 is greater than 1, and sec A is always greater than 1 because hypotenuse is greater than adjacent side. So this statement is true. What statement? The statement that says sec A equal to 12 by 5 for some value of angle A is possible. In fact, it's possible because 12 by 5 is greater than 1, and we have established that sec A should always be greater than 1 because sec A is hypotenuse by adjacent, and hypotenuse is always longer than any side in a right triangle. Right, so that's your justification. Then number 3. Go to 3. Subheading number 3. Okay, so here cos A is the abbreviation for cosecant of angle A. So the question is saying cos A is the short form. Abbreviation means short form. Abbreviation used for, exact language of the text, used for cosecant of angle A. True or false? Answer is surely it's false. We know, no? Cos A is the abbreviation for cosine, right? Cosine is written in short as cos. Cos is not the short of cosecant, it is the short of cosine. So you start your answer as false. Okay, and you can give justification because cos A is the abbreviation used for cosine of angle A. Okay, cosine of angle A, and not cosecant, and not cosecant of angle A, as the question is putting it. So this is false, right? And the fourth one, I think tomorrow the fourth one is number 4 is cot A is the product of cot and A. We have discussed this before also. So it should be easy. Cot A is